All right, we're going to do the 6 verifying trig identities under the heading verifying trig identities 4. So let's jump right into problem number 1 here. So problem number 1, I've got some kind of wacky fractions going on the left side that I'm going to try and work with. So let's say we've got cosine of x divided by secant of x plus sine of x divided by cosecant of x. Well, let's see. Secant of x is 1 over cosine. So if I multiply by the reciprocal, so I can get rid of the division, I'm really just multiplying by the cosine of x. And the same thing holds true for sine here. The reciprocal to cosecant is sine of x. So I've got cosine squared x plus sine squared x, which can be rewritten as 1. But I'm not actually trying to prove that I equal to 1. I need to now look at this and see if this is equal to secant squared minus tangent squared. Based on my Pythagorean identities, I do know that that's a true statement. So I can actually replace 1 with secant squared x, put the right variable in there, minus tangent squared x, and that's then the side that I was looking for. There's my squared. Okay, so problem number 1 is all done. Let me slide on over to number 2 here. So let's see, tangent squared x plus 1 is really secant squared x over secant of x. So one of those secants will completely divide out, leaving secant of x is equal to secant of x. So number 2 is now done. Slide on over to number 3 here. Ooh, this one's looking a little bit weird. Okay, so if I multiply this out, let's see what happens. So 1 times 1 is 1 minus cosine squared x plus cosine squared x minus cosine to the 4th x. Ooh, that might not be the best thing that I could have done here, but let's see what happens. All right, so 1 minus cosine to the 4th x. Now, I know what I'm trying to aim for, which is sines, and that did not help me get any closer to sines, did it? So here's one of the things that sometimes happens. Sometimes I'm actually going to backtrack out of this and see if I can't do this problem differently. All right, and that sometimes happens with these. So let's see. 1 minus cosine of x is really sine squared x. And then let me play with this a little bit. And if I replace cosine here, let me see what I can do with that. Okay, so this is going to be 1 plus, now cosine squared of x can be replaced with 1 minus sine squared x. So this is looking promising because this is going to be 1 plus 1, which is the 2 that I'm looking for. So this is going to be 2 minus sine squared x times sine squared x. Let me go ahead and distribute. So it's okay to try something and maybe realize it didn't work as well as you thought it would. All right. I haven't done this problem in a while, so trying to remember what was the easiest way, obviously it didn't happen. But keep in mind, again, when I first tried this, I figured, okay, I can multiply it out. It didn't work for me. But then I rethought about it and said, well, wait a minute, I need to get some signs here. So I replaced 1 minus cosine squared x with sine squared x and replaced cosine squared x with 1 minus sine squared x. So using a lot of those Pythagorean identities, we're going to be able to solve some of these problems. Or technically, we're not solving, we're verifying them. All right, so number 3, I now have the right answers in place. So maybe there's other ways to solve it. You can let me know if you've done this a different way. Let's go ahead and slide on over to number 4 here. Let's see. So sine squared x, and then let's see, 1 plus cotangent of x is cosecant squared x. So let's see, sine squared x, cosecant squared x is really 1 over sine squared x. Those cancel. I get 1 is equal to 1. Number 5 here. What fun is this? Oh, okay, I see it. And sometimes, again, take a look at it, try some different stuff. Maybe it works, maybe it doesn't. And if you see it, awesome. Here's what I notice. Sine squared x plus cosine squared x, these two together can get replaced with the number 1. So 1 plus tangent squared x is one of your other Pythagorean identities, which is really secant squared x, which is the right side of this problem. So number 5 is now done. Sometimes it just takes a little while to find them, and it's okay to do that. Play around with it, try a few different things, and as I said, the part of this that will happen is getting more familiar just through practice. All right, number 6. Number 6 is kind of a mess, but let me see if I can break this down. So we've got cosine of x divided by sine of x divided by cotangent of x. I think I got that all right. So let's see, that's cosine of x times 1 over sine of x. We're going to use the reciprocals here, times cotangent is cosine over sine. So if I multiply by the reciprocal, that's going to be sine of x over cosine of x. And everything is going to cancel out here. Everything's going to divide out completely, leaving you 1 is equal to 1. All right, so that's the 6th problem in that set. As I said, I will have the answer key that will have the simplifying problems that are on all the pages. If you have any questions or concerns, please let me know and I will help you out as best I can. Again, if you want to try one of these problems a different way,